Today we're going to talk about circles, and we're going to make sure we understand central angles and how to find the measure of them, arcs of a circle and how to find the measure of them, and then we're going to make sure we understand how to find the circumference, which should be reviewed for you, and then the arc length, which might be new. Okay? And it's key to understand that the measure of an arc and the length of an arc are two different things. Okay, and that's hopefully what we'll point out to you today. All right? So here we go. Sorry, some of this is hard to read. Circle, first of all, the definition of a circle is all the points in a plane that are equal distance, which is called the radius, from a given point, which is called the center. All the points in a plane that are equal distance from the radius to the given point called the center. Pause so you can copy the stuff. Just to make sure you're understanding the picture, the diameter is this blue line right here. That's the diameter. The red lines here are radii, two radiuses. They're called radii. The angle between the two radii is called a central angle. So in a moment we'll get the definition of what a central angle is. And then this yellow highlighted section of the circle is called an arc. And the arc is just part of a circle. Okay. Am I not finished with the picture? Down. Oops. Oh, we are recording. Okay, good. Move down just a little bit. So congruent circles have congruent radii. So to determine whether two circles are congruent or not, we just have to know what the length of the radii are. If the radii are congruent, then the circles are congruent. All circles have exactly the same shape, so the only difference is how long the radius is. Pause for a moment. A few more items we need to make sure we understand the vocabulary too. One is a minor arc. A minor arc is an arc that measures less than 180 degrees. And we label it with two capital letters. 2 points are on the circle and an arc symbol. Minor arc. Okay? It really doesn't matter if we start at A and go to B, or if we start at B and go to A. There's no significance in the order. So arc AB and arc BA would be exactly the same arc. Okay? A major arc has a measure more than 180 degrees. And you must use 3 letters for a major arc. Where A and C, in this case, would be my end points of my arc. And B would be just some point on that arc. If there was multiple points on that arc, then I could name it the same way. And multiple ways to name the same arc. A semicircle, or a semicircle, measures 180 degrees. It's exactly half the circle. And adjacent arcs share a common endpoint but don't overlap. Okay, we'll look at a picture of these things in just a few minutes. So I'll pause you and finish copy. Abbreviation here stands for addition. Arc addition postulate. We've had the segment addition postulate, we've had the angle addition postulate, now we have the arc addition postulate. It simply says if arc since the green arc, arc BC, is less than 180 degrees, then I don't use the third letter that's on that arc to name it. Okay? And here's just a note that arc ABC and arc EC are the same arc. I should use a congruent symbol there. They're the same arc, they're congruent. Two different ways of naming the same arc. They have to have the same endpoint and they have to go the same direction. Arc ADC, well, I'll stick with what I'm trying to tell you. We'll just use two. Arc AC is not the same as arc ABC. Arc AC is this arc. This is arc AC. Arc ABC would be this arc over there. They're not the same. Okay? So if the arc is less than 180 degrees, then we use two letters to name the arc, just the endpoints of the arc. If the arc is more than 180, then we have to use 3. Okay? Any questions on that? A major arc means it's what? More than 180, and a minor arc means less than 180. No 90s involved in arcs. Okay? We don't have right arcs. All right. Any questions on anything I zoomed through on this page? Okay, moving on. Circumference is the distance around the circle. Two formulas for circumference, you've seen that before. So to back up, the suggestion was the answer to circumference is pi times 10, and we said the diameter is all the way across the circle, passing through the center. And so since this radius was 5, this over here would be 5, so the whole diameter would equal 10. And so we get pi times 10. If they say to leave it in if they say to leave it in terms of pi, then you want to leave it this way. Circumference is equal to 10 pi. If they say to round to the nearest tenth, then feel free to use the pi button on your calculator and say 10 times pi, and then round it off. 31.4. Okay? You have to be a little bit careful. If they say to use 3.1415, then you really need to use 3.1415. Occasionally, depending on where you're rounding to, you'll get a different answer using 3.1415 than you will using the pi button on your calculator. Again, if you're rounding to the 10th, it's probably not going to matter. But depending on where you're rounding to, it may make a difference in the answer. So be very careful to use what they say to use. If they just say, use pi, or find the exact value, or they say round, I shouldn't have said that. They won't say find the exact value and want you to round. If they say round to the nearest tenth, and that's all they say, then I would use more than 3.14. I would probably use this. Or I would use my pi button on my calculator. Okay? If they say find the exact value, well, the only exact value is this right here. Because once you plug a number in for pi, I don't care how many decimals you use, it's no longer exact. Because as you learned in 8th grade, right, you found like 50 decimal places of pi. Am I right? Okay? So you're understanding that pi never ends. And so once you throw a number in for it, you're rounding it off. Even if you round to the 50th decimal place, you're still rounding. Okay? The book rarely says find the exact value. They almost always say leave it in terms of pi. But find the exact value and leave it in terms of pi really mean the same thing. Okay? Now, had I used the other formula here, this one, I would have said 2 times pi times 5, the radius, and 2 times 5 is 10 times pi. And so this is what I would have gotten, same as I did over there. If they give me the diameter, then I probably just want to plug it in. So what's my, in this case the diameter is 6, so what's my circumference?
6 pi.
6 pi. And this is centimeters. It's not area, so we're not going to throw a square unit at the end. It's just whatever that unit is, it's measuring length. Okay? Okay. This part's just a little bit harder. It says find the measure. M arc AB means the measure of arc AB. This is what it stands for, the measure of arc AB. So they want us to find the measure of arc AB here. Okay? Now they did not ask for the length of arc AB, they asked for the measure of arc AB. And what does our note say here? The measure of the central angle, the measure of arc AB is equal to the measure of the central angle that created arc AB. And so if I look at these two radii, they cut the circle into this arc right here, right? And so those two radii created that arc. What's the measure of that central angle? Couldn't hear you.
It's 120.
It's 120. Remember, the central angle is the angle whose center is at the center of the circle. I'm sorry, the angle whose vertex is at the center of the circle. That's the central angle here. And this measure of the angle is 120, so the measure of this arc is 120. Okay? The measure of an arc is equal to the measure of the central angle that created that arc. The central angle has the vertex at the center of the circle. Okay? Measure of an arc, length of an arc are two different problems. Okay? The measure is simply whatever the measure of the angle is. Alright? Now, if I want to find arc length, I have a formula that says the measure of the arc, and I just wrote the word arc in there because we can't have one name for every arc. Okay, every arc has its own name. So the measure of the arc divided by 360 times the circumference of the whole circle. And so what we're doing, this right here tells us the ratio of the circle we're looking at. Okay? We're looking at this one up here, it's 120 degrees out of the whole circle 360. So the measure of this arc would be 120 up here. That arc there would be 120. And so they'd be 120 over 360 times the circumference of the whole circle. So in this example here, the measure of the arc AB is what? 100 divided by 360. So 100 over 360 gives me the ratio of the circle I'm looking at. If I want, I can make those numbers smaller by dividing by 10. Just get 10 over 36. Times the circumference of the whole circle. How do I find circumference of a circle? Pi times diameter. Did they give me the diameter? They gave me a radius, which is 6. So how do I find the diameter? Times it by 2. So the diameter is 12. So it's 12 times pi would be the area, or I'm sorry, would be the circumference of the whole circle. Okay? How many times does 12 go into 36? 3 times. And 12 into once. And so my answer then, in terms of pi, is 10 times pi on top. On the bottom I have 3 times 1. 10 and 3 don't have any common factors, do they? So if they want it in terms of pi, it's arc length, so it would be 10 pi over 3 inches. If they say round to the nearest tenth, then I would just say 10 times pi divided by 3. It's going to be somewhere around 11, 10 point something. What is it if they said to round to the tenth? What is it? 10.5. Any idea how we could do a quick common sense check on this to see if our answer makes sense? Okay, but what's the value of pi?
About 3.14.
Okay, so it's really close to 3, isn't it? It's a little more than 3, but it's really close to 3. And on the bottom, we're dividing by 3. So if I had a 3 on top and a 3 on the bottom, would they cancel? And I'd be left with this number, wouldn't I? So since the pi is on top and it's a little bigger than the 3 on the bottom, then this is going to cancel with most of that, leaving me with a number a little more than 10. Okay? It's just a common sense check, not anything scientific about that. 3 and 3.14 are not the same number. I can't actually cancel those two out. Okay? But taking a number and multiplying by a little bit more than 3 and then dividing by 3, for the most part, I've not changed that number much. Okay? So that's why we get a number close to 10. All right. Any questions on that example? Concentric circles are 2 or more circles with the same center but different radii. Caleb, maybe you shouldn't be looking at this. After you've been concussed, you might see things moving at you. Concentric circles. Okay. Good thing I can't put this in motion. That'd really get you going. Thread inside. Leave the building. Concentric circles. 2 or more circles with the same center but different radii. So notice, I just changed the calendar.
Stop it. They're making fun of me.
Lesson 7-6, 3 to 43, 3 to 42 by 3s, and number 53. I want you to look at that one. Okay? Actually, the quiz is set up for Wednesday, not Tuesday. I was thinking it was Tuesday. Okay? And it will cover lessons 4 through 7, not 4 through 6.